This is a lab exercise captured on video that demonstrates how to use an embedded system based on the Intel Atom processor to build a computer-controlled advertising billboard. This lab exercise is taken from Lab 7 of the Dreamcatcher ME2130 University courseware. We will be using networking, various scripts, C programs, signaling, client-server communications, threads, and other techniques to build a computer-controlled advertising billboard. To get the most out of this video, you should have the lab sheet beside you for reference while viewing the video. Please download the lab sheet from this link. You may want to pause this video now so you can read the lab sheet first before proceeding with the rest of this video. The setup consists of a laptop or a desktop computer that functions as the host device and the Intel Atom-powered Qbox Mini 1000 intelligent system connected to an LCD monitor that functions as the target device. The host and target devices are connected to a Wi-Fi network. The target device, which is the Qbox Mini 1000, is a self-contained system that uses Wi-Fi networking and a web-based interface to access stored images in a shared directory on the host device and display the images on the LCD monitor. Images stored in the shared directory of the host device is uploaded to the target device and displayed on the LCD monitor. Let's begin the procedures to build a computer-controlled advertising billboard. We will perform the following procedures to build a computer-controlled advertising billboard. First, we will set up both the host and target devices by creating a shared directory on both the host and target devices. This directory stores the images that will be displayed on the LCD monitor that is connected to the target device. Then, we create a program using Simple Direct Media Layer or SDL to display images on the LCD monitor. Next, we create some shell scripts and C programs to launch the SDL program and to perform the functions of a billboard. We add a signal handler to the program, so the image displayed will change when a signal is detected. Finally, we set up a web server on the target device, so we can monitor the target device from the host device. When you have completed these procedures, you will have a basic computer-controlled advertising billboard. Setting up a shared directory in the host and target devices. First, let's do some setup on the host device. We will be installing a network file system so we can share a directory on the host device and allow the target device to connect. Ensure that the host device is connected to the internet. We will need a terminal console for the next few steps, so open a terminal console. Make a new directory. Let's name the directory Billboard. Later, we want to share this directory with the target device. To allow us to share the directory, we install the Nfs kernel server. We choose the Network File System or NFS, which is a distributed file system protocol, so we can share a directory from the host device and allow the target device to connect to the host device. We want to do it this way because the host device provides more storage space and processing power, allowing us to do our development work on the host device. Now, we need to configure an Nfs Share by editing the Nfs configuration file located in the /etc directory. Use a text editor to edit the Nfs configuration file and add the path to the directory we wish to share to the target device. Remember to save the modified file. Next, we initialize the NFS service. Determine the IP address for the host device. We will need it to mount the shared directory on the target device. Once the shared directory is mounted, the target device can access the files in the shared directory. In the next procedure, we are going to introduce and set up the target device. The target device is the Qbox Mini 1000 intelligent system. It is widely used in embedded systems, IPTV, home theater systems, or as a mini computer. The Qbox Mini 1000 is powered by an Intel Atom processor and comes with 1 GB of DDR2 memory and a 16 GB solid-state drive for storage. For connection to the outside world, the Qbox Mini 1000 provides USB ports, a VGA port, an audio jack, and Wi-Fi connectivity. The operating system on the Qbox Mini 1000 is Ubuntu, which is a Linux operating system. We will use this operating system as part of our Billboard design. After we have set up and created a shared directory on the host, we will now set up the target device. The following procedure is performed on the target device. Before we begin, enable super user privileges on the target device. First, we install the NFS tools. The NFS tools will be downloaded from the internet. Enter the following commands. When prompted, press Y to continue with the installation. Next, we install another program called Simple Direct Media Layer, or SDL, which we will use to display graphics. Enter the following commands. Then, we install a tool called ImageMagick, which we will use to scale the picture files into the correct size for display. Enter the following commands. Press Y when prompted. Now we mount a directory on the target device to the shared directory we created earlier on the host device. First, we create a new directory called Nfs Share. Next, we mount the host share directory to the shared directory that we created earlier on the host device called Billboard. Enter the following command. Now, the target device can access the files stored in the shared directory on the host device. If either devices create a new file or copies file into that directory, both devices will have access to the files. This completes the setup for creating a shared directory in both the host and target devices. In the next procedure, we will create a program using SDL to display graphics to the LCD monitor attached to the target device. In this procedure, we will create a program using Simple Direct Media Layer, or SDL, to display images on the LCD monitor attached to the target device. This procedure will be performed on the host device. On the host device, open the Billboard directory. In the Billboard directory, use this command to enable super user privileges on the target device. Using a text editor, create a file called sdl_disp.c. We will now create a program using SDL to display something on the screen of the host device. We write the code in the C language. After you have entered the code, save the file. Next, we compile the code using the GCC compiler. Remember to include the SDL library when compiling the code. Once the code is compiled, the executable file sdl_disp appears in the directory. To test the program we have just created, let's add some images to the Billboard directory. Now the Billboard directory consists of 2 image files, 1 C program, and 1 executable file. Earlier, we mounted the shared directory on the target device. Let's view the files from the target computer and try the C program we created earlier. From the target device, open the host share directory. Because the directory is shared with the host device, we can see the files we added earlier from the host device. Let's try the C program we created earlier. Enter the program name, the image file name, and the number of seconds to display the image. It appears our program is working correctly. In this procedure, we will create a shell script to perform 2 things. Convert the images inside a directory to the BMP format and execute the C program sdl_disp to display each image for 3 seconds. From the target device, we create a new directory called images inside the Billboard directory. We will use the images directory to store the images that will be displayed on the LCD monitor attached to the target device. Next, we create a shell script. Use a text editor and create a new file called sdl.sh. After you have entered the script, save the file. This shell script will convert image files inside the images directory into BMP files, and then execute the sdl_disp program that will display each image for 3 seconds. Enter the following command to execute the shell script. The script converts the image files in the images directory into BMP files, and then it displays the image on the LCD screen for 3 seconds. For this procedure, we will be adding a signal handler to the SDL program so that the image displayed will change only when a signal is detected. This will allow the SDL program to only do one thing, which is to read the BMP file and display it on the LCD monitor. The shell script, which we will create later, will make sure the image file is present, is in the correct format, and manage how long to display the image on the LCD monitor. From the host device, use a text editor and create a new C program in the Billboard directory. Let's call the program sdl_disp2.c. Enter the code that includes a signal handler, and then save the file. Next, we compile the code using the GCC compiler. Again, remember to include the SDL library when compiling the code. Once the code is compiled, the executable file sdl_disp2 appears in the directory. Let's test the new program, sdl_disp2. Enter the program name, followed with the image file name. It appears our program is working correctly. Now we will create a shell script to perform two things. Convert the images inside a directory to the BMP format, and execute our new C program SDL_DISP2, which includes a signal handler, to display each image for 3 seconds. From the target device, use a text editor and create a new shell script called SDL2.sh. Enter our new shell script and save the file. This new shell script converts the image files in the images directory to BMP files, and then executes the SDL_DISP2 to display the images on the LCD monitor. As mentioned earlier, the SDL_DISP2 program includes a signal handler that ensures the display images only changes once a signal is detected. Enter the following command to execute the shell script. As you can see, the shell script works correctly. Here is a view of both the host and target devices. Look what happens when we add some new advertisement images from Dreamcatcher into the images directory. Because of the shared directory, the target device can access the new images. The shell script SDL2.sh converts the new image files into the BMP format, and then the C program SDL_DISP2 displays the image onto the LCD monitor connected to the target device. In this procedure, we will install a web server into the target device so we are able to monitor the target device from the host device. On the target device, we install an industry standard web server called Apache. Enter the following commands and allow the Apache installation to finish. To check if the web server was installed correctly, go to the host device. Open a web browser and enter the IP address of the target device. This screen appears, which indicates Apache was installed successfully. Let's return to the target device to create a thumbnail of the image files in the images directory. Enter the following command to create a thumbnail file called thumbnail.jpg. As you can see, the thumbnail file is created inside the host share directory. Copy the thumbnail file into the web server directory /var/www. This thumbnail should now be visible in a browser from the host device. Let's go to the host device and have a look. On the host device, enter the IP address of the target device followed with /thumbnail.jpg. You can see the thumbnail of all the image files in the images directory. Let's return to the target device. In the following steps, we are going to create a HTML file to display the thumbnail file and modify our SDL2.sh shell script so that we can monitor the image files stored in the images directory and the image files that have been displayed. For our HTML file, use a text editor and edit the index.html file located in the web server directory. Modify the HTML file to display the thumbnail. Now, when you use a web server from the host device and enter the IP address of the target device, you will see the thumbnail of all the image files in the images directory. After completing the HTML program, we will execute the sdl2.sh shell script on the target device. Next, we modify the shell script sdl2.sh, adding the code that appends into an HTML file called status.html, the file names of images that have been displayed. Remember to save the file. We launch our modified shell script sdl2.sh and allow the images to be displayed on the LCD monitor. Now, we go to the host device and see how we can view the status of the images displayed on the LCD monitor. On the host device, open a web browser and enter the IP address of the target device, followed by /index.html. The thumbnail of the image file stored in the images directory appears. Now, we enter the IP address of the target device, followed by /status.html. Now we can see the images that have been displayed on the LCD monitor connected to the target device. Conclusion: we have demonstrated how we use the Qbox ME2130 intelligent system as an advertisement billboard, which we can control from a host computer. Here is a summary of what you have learned in this video. You have set up a shared directory using the Network File System or NFS. You have created an application using Simple Direct Media Layer or SDL to display the image files. You have created a shell script and a C program and configured a web server. Putting the programs you have created together with the Qbox ME2130 intelligent system and a host computer, you have created a computer-controlled advertising billboard. Thank you for viewing this video series. Going further, the advertising billboard system shown in this video works, but it is quite basic. Your assignment now is to extend the system further. You may refer to section 6 in the lab sheet that gives you some ideas and hints to guide you in creating new applications using the Qbox ME2130 intelligent system.